curiosity and wonder. Let's discover together. It's Science Wow.
Don't adjust your screens. We're doing an optical illusion where if it works, you're gonna see color on your side of the screen even though you're looking at a black and white video. Now right now you're looking at a negative image. So I need you to keep focusing right here, and in a matter of moments I'm about to switch this to a black and white video, and yet momentarily you will still see color, like right now. Pretty crazy, right? Welcome to Impossible Science. Today we're going to transform a black and white image into one full of color. Now it sounds impossible. In fact, this has been an idea for magic tricks for countless years as we try to find ways to make color appear at our fingertips. And whether it's done with a deck of cards or a magic coloring book, doesn't matter, because the real secret behind making color appear, turns out this one is possible through science. If we want to trick the eye, we should know how it works. If we take a closer look at the back of the eye, there's a thin tissue known as the retina. Now the retina is comprised of two different types of photoreceptive cells. There are rods and there's cones. The rods are responsible for detecting different levels of light, and they're also responsible for our vision at nighttime. While the cones, they're responsible for detecting the colors, the red, the greens, and blues in different combinations. Both the rods and the cones work together to send signals down the optical nerve and up to the brain, where the brain deciphers those signals to see what we're looking at. Now that we understand the pipeline, well, let's figure out how we can trick it. Okay, we're going to trick the eye by using what's called an after image. An after image is what happens when you engage the same photoreceptors at the back of the eye for an extended period of time, roughly 20 to 30 seconds. Now, what you don't notice throughout the day is that your photoreceptors in your eye are constantly being adjusted. See, you're constantly focusing on different things. You're looking at different bright lights and different color shades, and those photoreceptors are adjusting. Now, don't think there's only like a few of these things. There's about 90 to 120 million rods in your eye, and there's roughly 6 or 7 million cones in your eye. So you can see there would already be a lot of different adjustments going on throughout the day. But what we want to do is tire the same photoreceptors out for an extended period of time. So let's do the experiment again, and I'll walk you through what's happening. So here we go. I need you to focus right here. And I'm gonna stay as still as possible as I explain what's happening so that I can engage the same photoreceptors. What's happening right now is the photoreceptors in your eyes, the ones that are seeing the bright lights, are telling the brain that it's seeing bright lights, bright colors, while there's other photoreceptors that are detecting the darker shades and the darker colors. Now they're not working as hard as the ones that are detecting the bright lights. The ones that are detecting the bright lights are getting tired, and about 20 to 30 seconds of this, they're actually sending a weaker and weaker signal to the brain. The brain is starting to realize this is the new normal. When we switch to black and white, well, the photoreceptors that were not engaged as much the first time are now coming at full strength, and this is very overwhelming to the brain. And the brain instantly thinks it's looking at the negative. So let's give it a shot. And if you blink, you momentarily see color. In fact, you can actually look at a white wall and you should still be able to see color. That's the after image. Pretty crazy when you think about it. See, you can even put this into test. You can actually just look at a color wheel and you can see how our logo even was in the background was changing colors. Anything that was white, the inverse was black, just as much as those red, greens, and blues that the cones were detecting. The cyan in our logo looked like red just as much as green, looked like magenta, and you can actually see a color wheel in action, which I think is pretty cool. And until next time, stay curious, because the right question changes everything.